All right, everyone. Welcome back to Comp 426, Modern Web Programming. This is lecture 8. And so today, now that midterm 1 is past us, we have started a new module, which is going to be on React. So before we get started in talking about this, some announcements. So first off, amazing job on midterm 1. So I already graded them all on Friday, but unfortunately because a lot of people have been sick, there have been some makeups. So all the makeups will happen today. And so by the afternoon, the grades will be posted. So if you haven't already sent me an email about making up the midterm makeups will be today at 12 p.m. But if you cannot make that for whatever reason, email me immediately, even right now. That way, by the end of class, we can get that set up. Okay? So the average and median were A's, which is great. It indicates that all of you have the level of knowledge going into the next module, which will be great for kind of serving as the foundation. So very, very good work there. And then in addition, A3 Pixel Art Maker, which is the third assignment we'll be doing on Thursday. How many of you have started on that? Good. Yeah, good amount of people. So that'll be due there. We'll kind of briefly discuss this a little bit in a minute. And then also, since we're starting a new module, there will be some reading assignments. I've added these here. So reading 5, reading 6, due Friday and Sunday. You can complete them all ahead of time. They're based off of 2 chapters in the official React documentation. I think both of these are either 15 questions or less. So in total, it shouldn't take very long, but it will serve as a good way of practicing and getting used to some of the tools that we'll be using from starting today until the end of the semester. Okay. Are there any questions on announcements? All right, very good. So we'll start off with some recap here. So in the previous module, which is module 1 that we've been studying and we had the midterm on, you've learned about developing web applications through these 3 things, right? HTML for the content and the structure of our web page, CSS for styling. Together, HTML and CSS help us make the user interface. And then we've also talked about using TypeScript for adding functionality to our web page. And we connect these two. We connect the UI and the functionality together using event handlers. And event handlers were so far the primary way that allow us to react to some event happening on the UI and actually run some code when that happens. And so historically, this has been the setup for most of the projects that have been on the web, with the exception of maybe some PHP projects, right? So historically, these 3 files, these basic files and event handlers have been the way that we have built web applications, right? And it continues to this day on small websites, right? So if you are deploying, for example, small websites or blogs or something like that, you've maybe seen that HTML, CSS, and JavaScript together in their base model is what's used. But there are some challenges that we have along with this, and they start to come at scale as we begin to build larger and larger web applications. And so for those of you who've started A03, which is the Pixel Art Maker website, you've probably found, and hopefully, and I knew this going in because that's actually part of the point for the assignment as well, you've probably found it a little bit tedious. And the end result is great and it's pretty fun to use, but actually developing it might be a bit challenging, right? And the biggest challenge with this, and as you're working on it, you've probably found out, is not only trying to choose all of the correct event handlers and all of the stuff like that, but also we've had challenges with keeping what we call the application state, or the data that is underlying our application, and the UI synced together, right? So for example, on the Pixel Art Maker, as you draw on the grid, right, there is a 2D array somewhere in the back, I think in engine.ts, right, that's being updated with all the colors as you draw. But then also you need to go back and update the UI so that every grid is shown with the right color. Or for example, when you change your tool. So you currently by default, right, you have the pencil. When you change the eraser, you're not only changing the active tool in your TypeScript code, but you need to also sync then the UI with it so that on the UI, you see that the eraser is selected. And so this is the same note that I mentioned, right? That is a challenge at kind of at the scale of this project. In addition, another thing that you have probably noticed, if you've checked out the HTML, I didn't ask you all to make the HTML, it came, but if you have a free open, I recommend checking out the HTML. It's a bit cluttered. And the grid that we're drawing on is a 16 by 16 grid, which means that there are 256 tiles. And each of those tiles are represented by an individual div. So if you open up the HTML, you'll see 256 divs in there, each of them with an ID where it's like R1 underscore C1, R1 underscore C2, et cetera, for row and columns, right? And that is, not that great in terms of keeping our HTML in order. And so it would be nice if there was a way in our HTML to create custom elements that are then reusable, right? So for example, instead of having 256 divs, it would be nice if we could just make a row and then have that row repeat 16 times. Or even have some sort of for loop, like directly in our HTML that just kind of generated all of our tiles for us. In addition, we break up our HTML right now, there's comments in there, but we have like a toolbar at the top with all of the tools, and that, we repeat that many times, and these tiles repeat many times. And so we don't really have any composability, and we can't really reuse HTML. We have to copy paste all of our HTML if we want to repeat UI elements. And so I want you to imagine trying to create a much larger application with just the tools that we have, right? Like Instagram or Discord or Netflix or some other very, very large application that you might try and make with just the tools that we've learned of just HTML, CSS, JavaScript, etc. Sorry, I want to pause real quick to make sure. Okay, good. I am recording. Thought maybe I wasn't. Right. So this is a very, very big challenge, and it becomes nearly impossible at scale to just make applications with a bunch of event handlers. Can you imagine kind of the amount of HTML and just pure JavaScript or TypeScript event handlers needed to make YouTube, right? Like posting comments, liking videos, adding to a playlist, subscribing, turning on the notification bell, pausing the video, starting the video, and that's a huge amount of functionality. Writing all that in just one JavaScript or TypeScript file would be problematic, right? And so this is why, kind of in the modern web development world, using just plain HTML, CSS, JavaScript, TypeScript is not preferred for very large projects. And so over the years, developers have not just sat back on the sidelines, right? Web developers have come together and they've developed numerous tools and frameworks and libraries to help solve these issues and to ultimately make it easier for developers to make larger projects, something like Instagram or Discord, right? And the fun fact here is actually Discord, and I think even Slack and all these tools are actually built underneath using the tool that we're going to be talking about today. And so the one such solution ended up being developed by software engineers at Facebook, now Meta. And this particular solution is called React. Now, React is a JavaScript/TypeScript library that is used for doing two things. One, developing user interfaces, and second, for doing something called managing state. We're going to talk about that in a minute. Now, this particular repository is on GitHub. You can actually view it. Maybe I can pull it up here. Whoops. If there's a way that I can, right? So React, GitHub. Not sure why that's folded. All right, so you can see here, right, that there are now 232,000 stars on this project. There are thousands of people watching this repository. And so it is the largest JavaScript library in the entire site of GitHub. and the 10th largest project on the entire site. So out of all the millions of repositories in the world, this is the 10th largest one. And that's not just JavaScript. That's, that's includes everything. And it continues to be worked on and built up by the team at Meta for working on these React projects and working on the React library. And so the main goals of React are to solve two problems. The first one is to make user interfaces composable. So that's the first thing that we talked about. We talked about, in the context of Pixel Art Maker and how we have all these divs, can try and make it easier to reuse elements on our user interface. And then second is this thing here. So I write here, better manage state and UI updates when state changes. And what I'm referring to here is keeping the UI and the data underneath our project in sync. Right? So that is the problem, the other problem that we mentioned with, for example, changing the tool in on A3 or drawing on the grid. Right? We have to do all these manual updates. The goal of React is to make this much more seamless and to keep the data and the UI in sync. Okay. Any questions so far? All right, so we're going to be breaking these two goals down over the next 2 days. We're going to start off with the first one of making UI composable, right? And so the way that React does this is through something called React components. And the goal is to make, is to kind of compartmentalize UI and make it composable and make it repeatable. And so all a React component is it's just it is a UI element in React. And so the way that we define this, and I'll show an example here in the next slide, is that we create these functions which return something called JSX. Now, JSX is kind of a syntax extension on top of JavaScript that allows us to write markup directly in JavaScript that's similar to HTML. So you'll find that they're not the same thing, but they look pretty similar. And so we'll be able to have HTML, right, in quotes, so markup directly inside of our JavaScript code. And we'll see why that's useful in a moment. Right? And that ultimately will allow us to combine our HTML and our TypeScript functionality into one file. So it's combining UI and functionality. And that helps to keep things compartmentalized and to keep it in one unit that can then be reused over and over again. So here's an example of what this would look like in our code here. So you'll see here that our file extension for these type of components will be .jsx. And actually what you'll find is as we work on our own assignments, we'll actually be using .tsx, which is the TypeScript equivalent. But for simplicity here, I'm just going to keep it as JavaScript. So JSX, that way I don't have to add some type annotations to the top. Well, you'll see it. I'll show an example with TypeScript. It doesn't change much, but we'll just leave it as this for now. And so what happens is, like I mentioned in the previous slide, our UI elements are represented as functions. And so you can see here that I have a function. Whoops. Right, I have video listing, which is a UI, it's a UI component that I'm trying to make. And we have a function here. And then you can see here we return, and then what we return looks like HTML. Now, if you look at this, it's actually not quite like HTML because we have a lot of different items here in terms of our syntax. This is called, right, JSX. And so all of our components, we specify a component, we give it a name, such as, in this case, video listing right here. And then we return the UI or what our component should actually look like here in this return section. And you'll see that this code here is supposed to make this particular UI element. Now the styles are not, so I have not added any CSS. You can see that we kind of have where we have a thumbnail, which is like our video here. We have a like button, which is over here. We have a title and we have a description. Okay. So you can see here again, as I mentioned, our component functions return JSX that specifies the UI for our component. And another really cool thing is that our components can take in custom, what we call props, short for properties. And these are similar to attributes in HTML, right? So for a link, you could pass in href, and that would be the URL that you click on. here we can pass in entire JavaScript or TypeScript objects as input into our components. So in this case, I have a video listing. This is supposed to represent the UI for one video, maybe in some sort of video app like YouTube. And I can pass in an entire video as a parameter into my component. And the cool thing here now is that I could use this inputted object inside directly of my JSX, right? So for example, I can take the video's title and put it inside of my heading. I can take the video description and put it directly inside of a paragraph. I can even, and I'll show this here too, I think it's the next one. I can even nest other React components inside of React components. So my like button, for example, here could be defined in its own function. And that could take in a video as well as an input. So I can just take that video from up there and use it as the input for my other components. And it allows us to create this hierarchy where components can be inside of other components, and we're passing all these objects along. Okay. And then the last thing here that I had was that this enables composability, right? Because now we're able to take this one video listing that we made, and now we can use video listing 10 times in our, for example, in our in some other component somewhere. And now I'll have a list of these videos. I won't have to copy and paste all this manual HTML and have this long document. In addition, how would I have done something like this without React, where, right, if I wanted to put a video title or video description, I would have had to put like an ID here that's like video underscore description, grab it from the DOM in my JavaScript, and then say, element.innerHTML equals video.description. And that's a lot of code just to put in some string from our JavaScript directly into our UI. But here we can very easily build UI based off of inputs that we get from elsewhere. All right. Any questions so far? All right. So you're probably wondering, okay, I have this function which defines a component, and within my component, I can put other components. But how do I actually get a component on my web page? Right? Remember, when we talk about web pages, we have our browser loads some index.html file, and it loads some JavaScript. So how do we get our component to actually show up? And so we end up with something like this. So what I've done here, I've broken this up into 3 different parts. So let me see if I can draw here. My pencil always likes to turn off in the middle of these things. So I might not be able to draw today. Let's see. Yeah, okay, this is not working. That's fine. I can just use my hand. So this right here is an example of a component, right? It's a function. I've called it app, and it returns some JSX, which is just a paragraph that says hello world. And I want to display this component on my screen. So how React works is it basically hooks into our regular HTML, and then it injects our components inside of the HTML that would exist on our page. So for example, here in our index.html, we might have an empty page that just has a body and then have a div, for example, with ID app. And what we can do then is we can set that element. So we can grab this element using the DOM, right? So document.getElementById app. This will load this particular div right here into our code. And we pass it into this createRoot function, which is given by React. And so now React will know that this particular element right here is what we consider the root of our project. And then we can say root.render and then pass in JSX. So in here, I'm rendering my app component. And so what that'll do, right, is React will take our app component, render it into HTML, and place that HTML right here, where that div should be. Right? So by when we start off, we have an empty HTML that doesn't have anything. But then React, after the fact, goes in and modifies the HTML to input our component in there and to make our component visible. So you can see here through this step, React is responsible behind the scenes for manipulating the DOM. And it will go in, add the components that are necessary, and make it visible on our screen. But we do not have to worry about doing any of that setup. All we have to do is just this. We need to set our root, and we need to then render our component in there, and React takes care of the rest. Questions so far? I think it would be helpful if we show an example. So I'm going to pull that up here. There we go. Oh, now my drawing tool is on. That's interesting. Hide controls, hide controls, hide controls. Stop annotating. Okay, looks like, okay, there we go. It's gone. So I have here the exact same code that I showed on the slide. Oh, and by the way, I think I glossed past this. If you're interested in following along, it is at go.unc.edu/L08-426. You can also click on this link. I think this slide should be available. Yeah, I think there's quite a few people on the slide deck right now, so you can also click the link through there. And I want to show these two files here. I'm not sure why. Is there a way for me to take my index and drag it in here? Yes, I think through this. There we go. Okay, so I have here on the left and right, I have that's the same file. Wait a minute. Let's change that back to main. Okay, there we go. So you can see here, I have my HTML, and my HTML is empty. I just have one div here, which is, in this case, I made the ID root. And otherwise, our site's pretty empty. We have this script in here, which could be in the head. By default, this is just the way that the template was created. We load main.tsx, which is the entry point of our app right here. And we say, right, we grab our div, and we set it to our root, and then we say root.render. And now this app, which is over here, I'll pull it up. This is my app component. So all it is I just have function app, and I return hello world. That is my UI. And you can see on the right-hand side that hello world appears on my screen, right? So that is really nice. I now have my React component show up on my screen. And so we can try to extend this further and create custom components so that we can add to our site here. And so how we do this is I will go over to my, okay, let's see, that probably should be larger. And then if I close index.html, okay. So this is my file structure. And if you're following along, you'll see I have a lot of extra stuff here, which you can ignore. So like package.json, tsconfig is all the setup stuff, index.html. And then in here, I have this source folder, which I have two things. I have my main.tsx, and then I have my app component. Let's say that I want to create a new component. Let's just call this like student listing. Like I'm trying to list a bunch of students. I can create a new file, call it studentlisting.tsx. TSX is the file extension that we're going to use for specifying our components. And also another thing is you'll want it to be capitalized like so. The file name doesn't actually matter as much as the actual component name, but it should be capitalized. So I'm just going to keep it that way here. And now I have this empty file. Okay. So how do we create React components? Well, they have to be functions, right? So they're functions that return our TSX. And so how we write this is we first write export default. And the reason why we write export default is we want the function that we make on this file to be accessible across our entire app. And so export makes it accessible to all of the other pages. And then default means that I can just import the file, and it will, by default, just import the function that we make. And you'll see what I mean by that in a minute when we actually load this on another page. Well, right, export default. Now, there's two ways to do this. You can either use the arrow function syntax. You'll find, though, that the React documentation uses just regular function syntax using the function keyword. I'm going to use function so that it's a little bit more consistent. So if you're looking up something in the React docs, you'll see it. And I can call this here student listing. And this is just a base function here. So we have student listing. It is capitalized, which again seems really weird because usually functions are using camel case. It is React convention that all of the components are capitalized like so. That way in the TSX, if you're trying to refer to other components, you know what is a custom component versus what is built in. So that's kind of the reason why it's capitalized. And let's just say I'm going to return here. Usually we wrap JSX in a set of parentheses. And now I can write, for example, P, and then I'll just write my name here. And write your name as well. So this is a let me make this a little bit bigger. Okay, so this is a sample component. It just returns that one paragraph. And so now let's try and make this appear on our page. Right? So remember, in our main.tsx, we are rendering this app component. That's what we start off with. And so in my app component, I can try to add my new student listing component that I made. And so I can write here student listing, and you'll see that it automatically, and also if you get this error, I think you can type Control-C and then arrow up and enter again. The project, there we go. For some reason, whenever you create these new files, Vite kind of errors out for some reason. So you can just, again, I'll show it again. Control-C ends the current process, and then you can arrow up. Actually, Control-C ends the process, and then you can arrow up to the last run command. So StackBlitz runs npm install and npm run dev by default. So that gets our app started, and then it should show up, right? So you can see that my student listing component is now showing up on my screen. And I can copy this numerous times, and you'll see that now my paragraph is duplicated numerous times, right? So I have some reusability here with my items. Let's try and make this a little bit. Let's try and make this a little bit more advanced here. So I'm going to delete that, and so I have this one student listing. And let's say that I want my student listing here. So let me add parentheses back. I want my student listing to not only include my name, but also my major. So I can write here another paragraph and just say CS. And you'll see that I should have an error when I do this. And the reason here is a little bit, it's a little bit annoying. And I think if you've seen this before, you can probably tell. The way that these functions work is you have to return one single element. So whether if you have one paragraph, that's fine. Or if you have a div that has a bunch of stuff in it, that's fine. You just can't return two different elements kind of at the same level like so. So there's two ways of fixing that. We can either wrap it in a div, and so that will just fix our problem. So div, and you'll see that the errors should go away when I do this. There we go, right? The errors are gone. That's one way of doing it. There's also another thing called a fragment, which is if you don't want to apply a div in any way, let's say you've added some styling to divs and you don't want to have that, you can just use literally an empty component like so, or an empty element, which has nothing, no name at all. This is called a fragment, and it allows you to just group items together without putting it inside of a div. There are some use cases for this. You might see this sometime, so I want to show it. For simplicity, I'll just go back to a div because app.tsx already has that. So you can see both ways of doing it. And so now if I duplicated student listing, my name and my major will appear twice. But now let's say that I want to make this a bit more reusable. So I don't just want myself to be appearing on the screen. I want to have a bunch of different students. Well, I can make these two things, the name and the major, as properties to my component. So the way I do that is inside of my input, I add these curly braces. So what we're doing here is we're creating an input object. This object should have two fields, one for the name and one for major. Right? And so now that I have this, I should be able to supply a name and supply a major. And now I can, for example, replace this with name surrounded by curly braces. So whenever I add curly braces, that allows me to just inject JavaScript code right in there, or TypeScript code. So name goes right here, and then major right here. Now, you'll notice when you do this, and this is where this TSX differs just slightly than what I showed on the slide. You'll notice here that it complains that our binding, this binding element, has an implicit what's called any type, right? And that's the reason. Remember, TypeScript, its main goal is it kind of forces you to type all of your variables here. So just by supplying name and major, this doesn't really help us with adding type it doesn't really help us with adding types to our inputs. And if I try to add types like this, it will also complain. So if I add string and string, this will also complain because my input is an object, not really a type, like a specific type definition. And so the best way to go about this is to, like, we would have to add our type definition right here. Our type definition goes after the object that we're making. It's very weird. It's a bit hard to follow at first. And so if I put a type definition here, it makes a little bit hard to read. So what we're going to do instead is we're going to use the type alias feature of TypeScript. It allows us to kind of define a type, but give it a very nice readable name that we can then use. So I'll just call this here type props equals, and then what I put here is going to be the type of my inputs into this component, right? So I have this object which has a name, which is of type string, and then major, which is of type string. And so this right here is now kind of my type, my type definition for my input. It's an object that takes in a name and it takes in a major. Syntactically here, if you've seen or used JavaScript or TypeScript before, there's some fancy, TypeScript has some pretty advanced features, such as there's different things like type destructuring, which I'll actually read about in the reading, which helps to explain this a little bit. There's there's rest syntax, spread syntax, there's all these different things. And React uses all of this stuff pretty heavily. And so you'll begin to get a sense for how all this stuff works as you work more with it. At first, it seems a little bit dubious, but it helps. So now all I have to do is after my object, so after my closing parentheses, I can now just say that this object is of type props. And you'll see that now all my errors go away, because I have said that my input here is this object. That's the input into my component. And its types are, well, its two fields are name of type string and major of type string. Right, so that was a decent amount of work, but I recommend, especially if you're working at the beginning, just create on the front of every file, create one of these type aliases, props equals, and then supply the type for the inputs that you want. And then it makes it easier to kind of get all this set up, right? Any questions here so far? All right, I hope I didn't lose anyone with this type thing. That's the reason why on the slide I didn't include it, because I wanted to show it without types and then how it would actually be implemented with types. And so now that I have these inputs, name and major, I can go back to my student listing object and supply these inputs. So I can say name equals my name and major equals, for example, CS. And you can see that my inputs that I've supplied here into my JSX of name and major get passed in to these props, and then we can use those values in our code. And so this is really nice because now if I want to create different people, so like for example, if I wrote I have some TAs here, right? So if I write a TA's name, you can see that it appears right here on my page. I can add anything in here, like some sample name, and let's say major is Japanese, for example, it should just show up. And so now we've made our code significantly more reusable. Instead of having to write a paragraph, like 2 paragraphs for every single every single name and major, I've created a custom component that now I can use anywhere I want in my app. And it's easily reusable with these different props that we have passed in. And in the reading, you also see some fancy things like creating loops that allow us to repeat this. And I will show I'll write this really fast. I don't have to copy this. But if I were to write like comps, or just to show you what's possible, right? Const students equals, and let's say I said name, J major CS, and then name Jade major CS, like so. Sorry, wrong syntax here. I need that. You can actually, if you remember the map command that we talked about, or the map function from that one video, you can actually now go here and remember everything inside of this curly braces becomes allows us to put TypeScript code. So I can write literally students.map and then create a function that's like, so students.map student. And then in here, I can pass in student listing, name equals, again, it's a lot of typing here, so you don't have to fully get all of this, but I want to show you what is possible. Student.major, right? And let's see here. Let me restart my project because it broke again. There we go. And so you can see that now by using a loop, I can repeat directly in my markup here. I can create a bunch of these elements just based on an array. You don't have to know how to do this just yet. This will appear in the reading. I just want to show you how far we can go in making this repeatable. Now we don't even have to copy a bunch of these elements. We can literally put it in a for loop, right? So like that video listing component that I showed on the slide right here, right back here, you could have this inside of a loop and pass in like 100 videos and have a list of just 100 videos just by using a loop and by having a component, right? So something like YouTube, for example, you might want to include that rather than having just 100 different divs inside of your web page. Any questions there? And again, don't worry about the loops and stuff. You'll see it all in the reading. I just wanted to show that off there. Okay, so what does this ultimately allow us to do? Well, it changes the way that we actually think. It changes the way that we think about user interfaces. And that user interfaces are not just kind of this large list of elements, but rather we can begin to think about it in this compositional way. And so we can say then that user interfaces are composable and they can be used in many places. And we can even refactor and rewrite our code to make better use of these features of making these components that we can use multiple times that can have a bunch of different unique inputs. And it ends up making our code far nicer and far more concise. We can also think about UI then kind of in terms of a hierarchy. What do I mean by that? Well, I'm going to kind of not, I'm going to skip this piece. We'll have a discussion in a moment. Does anyone recognize this website by chance? Anyone? I feel like someone said it. Yeah, exactly, IKEA. So this is, I believe, I was trying to go into the code of these websites. I think IKEA might use React. I might be wrong as well. I think though their UI is built in React. There are many websites that are built in React, and so we can start to think about things in terms of components and how UI can be reused in multiple places. And so one way of thinking about this is maybe something like this, where our website, every single list item for a product, let's say in the IKEA cart, is a cart item. And this can be its own components that then we can repeat multiple times. Right? We can see things like our stepper here for increasing how much we want to buy. That is also reused, right? That's reused here, here, and here. So that could be its own component. Right? Our header at the top, maybe I should have made that box smaller. But you can see like there's that little warning, right? That says attention, we're currently experiencing delays, right? That could also be its own component. So that on any page I want to display an alert, all I have to do is just call my custom alert component. And it kind of creates like a nice hierarchy here between items. So like a shopping cart may contain multiple cart items. And a cart item may contain like, like a stepper and an icon and maybe a price and all that type of stuff. And so ultimately, what this does is just like with 301 and in Comp 301, you learned about composition, but with objects, that thinking of creating these compositional patterns really extends far beyond just objects in Java. It's a key tenet of software engineering. We're seeing it here, where even on the UI, we could think of UI in this compositional way. And it's also key tenet of refactoring. How do we make our code better by kind of making things a bit more composable? Another example, and you'll actually begin, you'll see this website. So this website right here, this reading one will be this drop down, reading two will be this drop down, at least for React. So you'll see this site a bit. But you can even see an example on React's own website. So here we have another, we have kind of a product inventory of fruits and vegetables. And you can see that that page can also be broken down into these components, where like these items here are product rows. This here is a product category. You can see how these things are repeated, right? I have 6 of these, I have 2 of these. I have a search bar, which I might be able to use in other places of my site, etc. So we have this kind of compositional relationship here. Any questions? All right. So the last thing I want to do, and I believe we should have this open now in Gradescope, is I want you to think about this page. So this is another one which you may recognize from somewhere along your journey through all the way to get here at UNC. This is another website which I believe is also, again, I might be wrong. I think I was looking through. I think this uses React, and so I would like you to think about, given this page, what are some example components that you can make out of this? And so you can talk amongst yourself for a few minutes, and we'll come back together and submit maybe a list of different components that you come up with on Gradescope. That'll be attendance for today. And so feel free to get started. We'll come back in a few minutes. All right, looks like conversations have died down. Does anyone have any ideas on sample or example components that we could derive from the Khan Academy? Any ideas? Yeah. Exactly, right? So this is one thing here that's pretty visible in terms of it being reusable, right? So I'll kind of draw right here. Exactly. Very good. So our units, right? So we have unit 1. This is a JavaScript class. So unit 1, unit 2, unit 3, that's repeated all the way down. So those could be example components. Very good. Any other thoughts? Yeah.
The navigation bar to the left.
Yeah, like this right here. Yeah, exactly. Very good. So right here, you can notice that these units are like we have unit 1, unit 2, unit 3. Those look very similar. And so this is kind of this is in a list. So we could have something like a unit component, and then you could have like a sidebar component. And so then no matter what page you're on, whether you're on the computer programming class, or let's say a math class or a science class, you can reuse that sidebar in all of those different places. Very good. So those are kind of the main ones. There are some others that you could imagine, like for example, even within this component, this could be one right here, like this top bar of the unit. So like maybe unit header could be one, because that's that might be used in other places. There are like this top section here with the information about the course could be even our entire sidebar or our entire top bar here with the search bar and the kind of Khan Academy header. That is used on all the different pages. So that could also be its own component. Very good. All right. So you can kind of begin to think. And well, by the way, just note that the Gradescope submission is open. So make sure that you submit. So this is one sample site, along with many others. And I really recommend as you go on these different sites, even for fun or for whatever, when you're, in your downtime on YouTube, for example, or TikTok. Does TikTok have a website? Actually, I have no idea. Does it? Or is it just an app? I don't know. Okay, well, anyway, there might be a website for that. So if you're on one of these sites, I recommend just thinking about how this site may have been made with components. I can tell you Instagram is made in React. So everything on Instagram is probably one of these React components. And so it's really good to begin thinking about this because as you're making your own apps, coming up with, okay, what do I make as a component and how do I combine components? All of that becomes easier as you begin to build this sense of how do we build these compositional user interfaces. And so kind of as a recap here, right? We said that React is a library for developing two things, right? User interfaces here. So that's kind of what we talked about. And then also managing state, right? So we said it's the largest JavaScript library. And today we talked about, today we talked about the first one, making user interfaces composable, and that's done through React components. And then on Wednesday, we're going to be talking about the next piece, which is trying to have our UI that we make and the data underlying our app, how to keep that in sync and how React helps with that, right? We have 2 minutes, so there's not as much time to continue working, but if you want to get started on A3 or work on any readings the next minute or so, feel free. Other than that, you can leave early. See you all on Wednesday. And if you have any questions, feel free to come to office hours for A03.